Good morning. My name is João Santos. I work at the European Commission based in Brussels, and I'm the Deputy Head of Unit responsible for vocational education and training, for apprenticeships, and for adult learning. I'm very grateful for the organizers to have invited me to this international convention on smart cities. And I think it's always important when we're debating the future, when we're debating innovation and strategic plans, that we always think about people, and in particular the people that are going to implement the strategy that we are thinking of. And quite often this element of skills is forgotten. And thank you to the organizers for not having forgotten this time. And I'll be here today presenting you an initiative that we are taking forward at the European Commission on centers of vocational excellence, which has the aim of creating local skills ecosystems to support innovation, regional development, and smart specialization. But before going on to the initiative that I came to present you today, I would just like to mention that the European Commission is also taking forward another initiative, which is called Intelligent Cities Challenge. And the aim is to support the growth and innovation in cities, but not any kind of growth, growth which is based on a social responsible approach, intelligent, as well as green and sustainable. So this, I would recommend that you have a look at this. The people that might be interested, you've got the internet link on the top left corner of the slide. And I think it has quite a lot of elements which are similar to the ones that you are going to debate throughout this conference. Now, going to what brought me here today, this initiative on centers of vocational excellence, I'll try in the next 15 minutes to focus on three topics. The first is innovation and how innovation happens. The second is how are we, with this initiative on centers of vocational excellence, trying to support innovation at the local level. And then the third element is how are we at the European level not only providing policy guidance for this initiative, but also the funding instruments and support services to take forward. So I would maybe start by telling you a small story that usually people don't remember, because when they associate innovation or when they think about research, it's always thinking about academia and these top thinkers that go into some forest in an isolated place, that you give them some money and they conduct research and voila, a brilliant idea comes out. But in fact, if you look at the way innovation happens, quite often it's not because of these gigantic top-down projects, but in fact from small things that happen, of people that have the curiosity, that have the entrepreneurship, the critical thinking, the will to change things that change the way life works. And just a small anecdote, this one about James Watt. I'm sure you've heard about it, but he wasn't a researcher. He wasn't someone working in one of these mega research projects. In fact, in the 60s, he was an instrument maker and repairman at the University of Glasgow, and he was asked to repair a model of a new pump. In fact, this guy, who was a repairman, as I said, not a university professor or a researcher, identified the problem, solved it, and set in motion what was then the Industrial Revolution through the steam engine. But this is just to tell you that, sometimes innovation happens not because there's objective intention of having it, but because of people in their everyday life that see a problem and want to solve a problem. And that's how innovation works. And these people that usually have this kind of approach come from vocational education and training. So from people that have a hands-on approach to things, to solve things and to make things work. And in fact, there's a Finnish professor that recently conducted a study in which he looked at the two types of ways in which innovation happen. The science-based innovation, the one that I told you that you have a certain amount of money, you get the right people on board, and they conduct research to solve a certain problem with a certain objective. And then you've got the practice-based doing and using and interacting kind of innovation that happens from, as I said, people that are in a production line. They see a problem, they try to understand what is going wrong, and come up with a solution for it. And this kind of innovation is, in fact, what the majority of innovation is all about. And as I said, for the vocational education and training system, this is particularly important because the kind of people that we are forming, the kind of people that we are educating are those that come from our vocational system. So we have to have this in mind because we've got to pass to them this kind of critical thinking, this kind of problem-solving approach, entrepreneurial attitudes that help them then solve problems. And this is why this is a short introduction of why vocational training is important and why the centers of vocational excellence fit well, I think, in the issues you're going to discuss over these days at this conference. So what do we want to do and how are we doing it? First of all, we've conducted quite a lot of research, and we saw that for a skills ecosystem to be built, it is not enough that the education system works on its own, that it just tries to identify what the problems are and then try to come up with curricula that would equip people with the skills that they need for local development. In fact, if the education system works by itself, it will be missing the big picture, because the reality today is that because of the green and digital transition, change is happening so fast that the education system by itself is not capable of grasping the magnitude of change that is out there. Therefore, it needs to link with a set of partners, and I'm talking about companies, public employment services, regional development authorities, urban authorities that have a planning responsibility. It has to, of course, also engage with individuals. Individuals have to understand that their investment in upskilling and reskilling is not something in abstract that someone is telling them that they have to do, but in fact because they can gain from this. They can have better employability prospects. They can have better rewarding jobs and better career opportunities. So basically the idea is that in order for a skills ecosystem to be developed, you really have to bring a wide set of partners to the table so that there is a constant interaction between all of these people, including, and I'm talking about going beyond education and training, social policies, economic development policies. There has to be a link with the skills element, because if we just continue doing them at a high level without then thinking, what does this mean in terms of skill development? How can these vocational schools, how can these universities of applied science contribute to these innovation plans? We are going nowhere. So this is basically what is at the origin of the initiative that we are proposing. And for that purpose, you might know that the European Union, we are 27 member states, and of course, each education system is very different to the other. The German is very different to the Greek, to the Portuguese, to the Spanish, to the Swedish. However, we at the European level, we have to come up with policies that at the same time address problems, but that fit to the specificities of each country. So what we did is a mapping study in Europe to see how vocational excellence happens, because there are already many examples throughout there where vocational excellence is happening. And we tried to identify, in spite of all the different education systems, is there sort of a silver thread that whenever vocational excellence occurs, there's something that we find constantly in these different approaches that exist out there in the 27 member states. And what we saw is that there are three key success factors, if you want. First of all, for vocational excellence to happen, you need strong and enduring relationships and partnerships. It means that you've got the education system closely linked to the regional development system, to the social partners, to companies, to universities. So it's not only one education system focused only on its own belly button, but really open to what is the reality, the social economic reality of the region or the city where they are operating. So this idea of comprehensive partnerships that are sustainable, they're not there just for one single project, but they're really there over time. The second element is that in order for vocational excellence to happen, it has to be firmly anchored in regional or urban, which is the case of what you're discussing today, urban framework. So there has to be a link between what the education system is providing in terms of skills and what are the strategic objectives of a region or a city or even a country. The third element is that unlike what has been the reality of the past, the vocational system has to provide much more than simple qualification. It's not the matter of receiving every year 300 learners or 1,000 learners. They go through the process of learning during 3 years. In the end, they get the qualification, then bye-bye. It's your problem to go out in the world. In fact, it has to look at a more comprehensive way. It has to see how it can support small and medium-sized enterprises that will need upskilling and reskilling of their staff to be able to adapt and contribute to these green and digital transition. It has to be capable of providing validation of non-formal learning that adult learners have. It needs to provide guidance for people that don't know in what way they should upskill and reskill. It really should look at the skills development in a much more comprehensive approach than most vocational centers have been doing until now. So these three elements are crucial. They are sort of hygiene factors. If vocational excellence is to happen, this has to be in place. And we've clustered the kind of activities. Remember, I told you that it has to be involved in more than the typical just giving a qualification. And we've seen what kind of activities are usually undertaken, and we've grouped them under three big topics. We've identified basically 25 kinds of activities. Not all the centers are doing them. Some will do more focused on one set of activities, others on others. But we try to sort of list what do you quite often see. And we've grouped them under three classes of activities. One is teaching and learning, the other one cooperation and partnerships, and the third one governance and funding. And just to give you an example, the yellow activities that you see there are under teaching and training. The green ones that are coming on the screen now are about partnership and cooperation, and the blue ones about this governance and funding. So these are just examples of activities. I'm not going to go through all of them because we have a document I can share with you where we describe the 25 activities. But just to tell you that vocational excellence to happen, the education system really has to go beyond just providing a qualification for the young people. It has to have a big focus also on upskilling and reskilling, have partnerships with companies for apprenticeships, for anticipating future skill needs, and these kind of activities. So this is how we've conceived the concept of centers of vocational excellence. One important element, and that's, I would say, the beauty of Europe, is that we want these centers of vocational excellence not to work just in the city where they are operating or in the region where they are operating, but really developing their work and learning and sharing know-how with transnational networks. So what I mean is that there would be a center of vocational excellence, for example, in the city of Madrid, which is cooperating with another one in the city of Amsterdam, and they are sharing experience. They are trying to pass to each other the knowledge that they are developing through their implementation of vocational excellence, and that each partner doesn't have to reinvent the wheel when someone else has done it. And what we are doing basically is with European funding, supporting initiatives that want to have this kind of approach. So if there's a set of partners in one city, let's say Berlin, that would like to cooperate with others in other cities, in Copenhagen or Lisbon, that would like to work together to come up with these kind of approaches, we at the European Union level are supporting these kind of projects. So this is the way we are taking it forward. Now I'll quickly tell you what we are doing in terms of funding. This is, as I said, a new initiative, the platforms of centers of vocational excellence, that's where the COVs come from. And the idea is that we first wanted to test this pilot because it was a new concept that we were developing. And in 2019, we, for the first time, launched a pilot call. We had limited funding for this. But in any case, we managed to attract very good quality projects. 5 of them were funded with Erasmus Plus funding. You'll see that I've got them here. You've got the links there. You've got the topic in which they are focusing. We have one led by the Basque country on advanced manufacturing. Then we've got another one led by Italian consortia. But as I said, it's led by one country or group of partners in one country, but it includes partners in other countries as well. At least 4 countries have to be involved. There's one on, as I said, running right now on cultural and creative industries. There's one on cloud computing, another one on Internet of Things in smart manufacturing, and one in the Netherlands on a water sector. So these are projects that are already applying these concepts that I explained to you before, that are running. And in fact, from this first call in 2019, we were quite amazed by the demand. And in 2020, we launched a second call. And this second call, you've got a summary. This is a test for your eyesight, this slide, but it gives you an idea of what were the applications for this initiative in 2020. We had 55 applicants. We only had funding for 5 projects. And the demand of funding was around 180 million euros, which is quite a lot. 52 countries were involved. And quite surprisingly for us, and positively surprising, was the fact that we had not only all the EU member states involved as partners, but also 25 non-EU countries involved, which is quite a positive development for us. We were quite encouraged by this, in the sense that the initiative is attracting interest not only from Europe, but also from partners outside Europe. I should say that we had around 1,324 organizations just in this call of 2020. With, as I said, it was still a pilot project with limited funding, but we were quite amazed by the number of organizations that were interested. And we saw that quite a lot of them were from partners from outside the world, as I said, but from Kenya, Canada, Singapore, the US, which I think is quite encouraging for giving us a good direction of what we should continue to do in the future. You've got here in the slide just a listing of the countries that were involved, of some of the countries that were involved. You see everything from Mozambique, Nepal, Netherlands, of course, in the EU, but really you've got a strong variety of partners coming from all over the world. In 2020, as I said, we had funding for 5 projects, but the quality of the 55 projects that we received was so high. We would have loved to fund many more, but unfortunately the amount of money we had did not allow it. But in any case, the quality was so good that we managed to go back to the EU member states and told them about the quality of the applications, and they gave us 8 million euros more, which allowed to fund 2 more projects. And in fact, this year we funded 7 projects, and you can see in each line you've got the title of the project, the sector it covers, the countries that are involved in the project, the grant that we gave, who is the main coordinator, and the amount of partners involved. You see there's a gigantic amount of partners involved in these projects, and quite surprisingly, not surprisingly, I would say, quite positively, is the fact that a lot of them are focusing on green. You even have urban green landscaping, green innovation, green economy, but you also have traditional sectors like the furniture sector. You've got the finfish industry, a project led by Norway, and you've got one project also on social inclusion with the urban dimension, but trying to reach out to people that would otherwise not fit in the education and training system, and provide people that sometimes are, come from unfavorable or disadvantaged groups, and are given opportunity through vocational education and training, and given the opportunity not in abstract, but something which is concretely related to the strategic objectives of a certain region or of a certain city. And this, I think, is a very important element to have in mind. Now, of these projects, you remember I told you we have around 25 activities that we've seen that the Centers of Vocational Excellence usually take forward. And what we saw is that of these 25, the majority of the projects had a big focus on business education partnerships as one of the key activities that they were involved in, but also on governance and stakeholder involvement, focusing on both initial and continuing vocational education and training, on new teaching and learning methodologies, taking advantage of digital technologies, also working on common curricula so that, they didn't have to invent certain occupations, certain professions. It doesn't make sense that the Greeks and the Portuguese and the Germans are all, trying to come up with the formula. It's better if they work together and share their experience, and then the formula they come up with is common and a result of a dialogue between all of these partners. So this is basically just to tell you the kind of organizations that we managed to attract with these pilot projects, were everything from vocational schools to social partners, small and medium-sized enterprises, higher education institutes, universities of applied science, research institutes, local public authorities. So as you can see, the element I mentioned in the beginning, that you need to develop skills ecosystems, you need to bring a large group of countries. In fact, this is what we managed to attract with these calls we launched on the Erasmus Plus, and we are quite happy with the results. Now, this is just a slide. I'm not going to repeat myself, but it will be distributed to you afterwards. It's a sort of the concept of vocational excellence in a nutshell that provides you with the essence of what my presentation was all about today. And if you'd like more reading on this initiative, I've got a list of bibliography that you can have a look at. So this is basically what I wanted to tell you, and I'm happy to receive any questions you may have in the next few minutes, or if you want, even after this conference, you can send me an email. In the first slide, you've got my email and also my LinkedIn and Twitter accounts, and I'm happy to continue engaging with you. And I hope you don't forget, whenever you're talking about strategies for the future, innovation in cities, never forget that at the end of the day, the success of your strategies will depend on the skills of the people that are going to implement them. It's not only about, big researchers, big ideas. Think about how they're going to be put on the ground, and that you need people that are qualified, motivated, and capable, understanding what you want to achieve and can contribute to it in a positive way. I wish you a very successful event. Good afternoon.
Hello, and thank you for listening to my presentation today. This is joint work between myself, Henning Schulzrinne, and my PhD students, Jan Janak and Luo Yao. I want to make the point today that the smart city is more than a network, more than 5G, but it is about creating a flexible, heterogeneous, and programmable infrastructure. What are some of the challenges for the smart city? Smart city is clearly not just a city-scale smart homes. It combines many more sensors and actuators operated by many diverse and often conflicting sectors and administrations. It is not meant to be application-specific or vendor-specific. Thus, there are interactions everywhere. In particular, that means we need to decouple the IoT function, the sensor and the actuator, from device identities if we want to be able to reuse the same sensors and actuators for multiple functions. It is indeed an IoT ecosystem consisting of living organisms, non-living components, and all interacting by communications. There has been a lot of discussion that 5G is going to dominate the smart city communication networks. I don't think that's likely, simply because the variety of networks that we have or likely to have offer different advantages and suffer different drawbacks. For example, in some applications, the low monthly cost may argue for a Wi-Fi solution. In others, a regional but outdoor-dominated application might be better served by LoRaWAN or a narrowband IoT solution, and we are likely to have applications specific, for example, to connected vehicles or agricultural centers or remote areas. Thus, we're going to be faced with a challenge of combining many networks, many network addresses, and many network administrations across the smart city application space. Our approach suggests a directory-based mechanism. Why should we use directories as a core part of a functioning, extendable smart cities ecosystem? They allow us to manage the growth of data. They can allow us to discover not just sensors and actuators, but also time series and data stores. We can discover resources. Again, not just sensors and actuators, but also transformation services. Most importantly, and the focus of this particular presentation, they allow us to hide changes that happen in a large ecosystem by providing a name resolution mechanism that is meaningful to the application and independent of the details of the hardware and vendor. They also allow us to share data, since they provide a common reference so that we do not have to be concerned as to who operates a particular device or service. We will be describing here a location-based, hierarchical, and distributed system based on such a directory, managed by a separate administration or a federation of administrations. And importantly, we need to, from the very beginning, support access control for both the directory lookups and the actual access to the service and device. The first component is geospatial naming of IoT services. Let me step back a minute and emphasize how important programmability has been for networking services in general. Nobody wants to program raw protocols, whether that's TCP or HTTP or MQTT. Indeed, one can argue that the most significant advances in making the internet usable to a wide variety of applications were not just the protocols, but also the APIs and programming services that went along with those. Starting in the early 80s with the socket API still around, the Java networking APIs, things like PHP that allows you to treat network input as script variables, and Ruby on Rails a number of years ago that simplified common network interaction patterns. On the other hand, we have plenty of examples where protocols and frameworks failed the test of programmer hate. Programmers just didn't like to create those, partially because of complexity, partially because it was hard to see what exactly was going on. For IoT, this will be even more important because most of the people programming IoT services and the smart city specialist will not really be programmers and software engineers by trade. They will be people like data scientists, and they certainly don't have a protocol background. One of the most important aspects of programs is naming. For IoT, this is even more important because inadvertently addressing the wrong device could cause significant damage in the physical world, or indeed could cause the system to cease functioning, and often silently, as in it will appear to be working but not actually perform its task. Currently, many IoT systems rely on low-level naming, often related to the network address. These don't work. IP addresses can change. NATs make IP addresses non-unique, particularly across administrative domains. Even MAC addresses can change when a hardware swap out occurs. The same device in terms of function is replaced by some other device with a different Ethernet interface. Domain names seem like a good option, and indeed in some cases they can work, but they're often unpredictable. They're often assigned automatically based on IP addresses and thus suffer from the same problem. They're assigned randomly, or they're assigned based on the manufacturer name as opposed to the actual service they provide. So what are our requirements? We want to have something that has no dependency on hardware or network topology. It needs to be independent of the administrative domain. And most importantly, the semantics of a naming should be meaningful to programmers. That, among other advantages, will likely reduce the number of errors that occur simply because it is clear to a observer of a program what the program is supposed to be doing, as opposed to guessing that this is actually doing the right thing. And we also want to have the capability for a programmer to easily address both a single device as well as a collection of devices, or have the ability to have fallback devices that automatically get drafted. So the first available device gets programmed into the functionality. So what is the kind of scale that we're talking about for smart city applications? Just as some examples, the largest number, if we were to look at energy type of applications, we're looking at about 136 million residential meters. We're looking at probably several tens of thousands of traffic lights, about 5 million parking meters, which just New York City has tens of thousands. Then we have about 270 million cars and trucks. And we have also a very large number of light posts, estimated at anywhere between 26 and 44 million in the US. They often have the advantage of being connected to fiber, so they make natural points of network attachment. So what are the concerns and advantages of geospatial IoT device naming? First, IoT device names are primarily meant for people, not for machines. So they should be meaningful to people, including programmers. Think of that as a program function variable names in traditional programming. Indeed, for many IoT devices, think of a home automation type system, we typically refer to these physical objects by their location. We talk about the light switch in the living room. But even for smart cities, location is one of the principal distinguishing factors. We talk about the security camera at a particular intersection. Indeed, we use that as a classical reference in smart speakers, for example, where we refer to the device by its location. We don't talk about the manufacturer of a device, certainly not the network address of the device. Thus, we believe that intuitive IoT device names often have a geospatial component. It is easier for people to use and understand. That's not always the case. For some mobile applications, for example, that may not be particularly relevant, or for quite complex, let's say, manufacturing systems, function and other references may be more appropriate. But for many smart city applications, we believe that geospatial IoT naming for programming and user interfaces is the appropriate approach. To illustrate what would this look like, this is a kind of pseudo-programming model where in pseudo-Python, where we would want to discover devices in a certain location of a certain type. And so we would simply enumerate those and then, say, output the concentration of carbon monoxide, say. Or we could envision an SQL-like interface, possibly even a real SQL database as the backbone, which allows us to do all the standard queries and indeed leverage the geospatial functionality that is embedded in many common SQL database systems. So if we want to map IoT devices to locations, we have some sources of that location data. Google Maps is one possibility, OpenStreetMap, building on information management systems, and just simple, good old-fashioned floor plans. They have trade-offs shown here. Generally speaking, we believe that OpenStreetMaps combined with floor plans provide the best combination, primarily at least for indoor type of smart city and building automation applications. We have been exploring a prototype to use multiple user-accessible data sources, in particular to use the OpenStreetMap building data. It provides polygons in GeoJSON format, and then indoor plans, the fire escape plans, and similar type of readily available plans. Now, some smart cities will have more formal data available, GIS systems, so they will certainly have higher quality data in that. But for many more localized applications, relying on cheap and easily accessible data provides a quick way to get started. We have been building systems to convert this raw data to a geodatabase, essentially combining floor plans, such as the one shown here for the floor where our lab is situated, with the OpenStreetMap data so that the floor plan is appropriately aligned via reference coordinates, and then we assign names to those to be meaningful. What do we get? We get a database of GeoJSON objects that are in WGS84 longitude-latitude format, essentially a 2.5D model, largely XY coordinates, but augmented with floor information. And then we import those into the MongoDB or Postgres databases. Again, this does not preclude use of a real JS system, but this provides a low-cost, easy-to-program mechanism to get a large fraction of the same result. So we then create a directory database of IoT devices, each provided with a longitude-latitude information, in addition to additional civic data, such as street addresses and room numbers and so on. And then we also provide an API that allows us to query that data. But naming devices is not sufficient. We also want to provide access control so that only authorized users can access and change the data for IoT devices. So access control, can offer a variety of factors in making that decision. Well-known attributes-based or role-based or identity-based access controls. In multi-administrative type of settings, the biggest challenge is not defining those roles and attributes, but providing reliable sources of those that are understood and trustworthy across administrations. That remains a challenge. We can use time. So, for example, we can restrict access to certain time of day or also to certain frequencies of access. So, for example, we might restrict less privileged users to infrequent access, as that often addresses concerns about privacy or the ability of external users to either intentionally or inadvertently overload the system. However, we were focusing here on the third approach, namely using geospatial access control. That is less well understood than the other mechanisms, but because it is rooted in the physical world, we believe that it provides an intuitive access control component that can kick in when some of the others may not be as appropriate. Again, this is likely to yield an access control system that is a combination of all three, not just role and identity and attribute, but time and geospatial information. Indeed, we can imagine that access control on a university campus is a good example of that. It is typically based on time of day. It has some notion of role and identity, but in many cases is also based on spatial properties. So if you are in a certain place, you gain other rights. We use access control based on geospatial relationships in traditional systems all the time. The light switch is a classical example. We do not put passwords on light switches most of the time. but we simply assume that somebody who is in a room has the authority to turn the light on and off. So we provide write access if you're near a particular object, and we might only want to provide read access if you're further away, thus limiting the damage that a far-away attacker can do. We might also want to have a separate access right for discoverability, independent of the access rights given to control. So, in summary, we propose that we want to use identity and role if the identity of the user is known, but we do not need identity in all cases because in many cases, simply the position of the entity, if verifiable, is sufficient to distinguish between authorized and unauthorized use. In our model, since location is not precise in most cases, but is really an uncertainty ring, we have the simple rules that if a probable location does not overlap with the authorization area or only partially overlap, we deny access. Only if the probable area fully falls within the authorized area, then we grant access. And each IoT device can independently determine what kind of a right it grants based on the size of that particular right access area. In summary, we believe that we will have a combination of many access networks for a smart city, indeed an Internet of Things. But the hard part is not the network. We understand that pretty well. The technology is likely to change over time and will likely combine a variety of network access technologies. The software is likely going to be the far larger challenges. It needs to be able to be created by domain experts. It needs to be extremely reliable and it needs to be maintainable over decades. We believe that directories can play a crucial role in hiding dangerous details that programmers should not incorporate into their programs and provide a natural means of implementing both discovery and access control. In particular, for smart city, geography is the most natural component of both the naming and access control, complementing some other like function or identity-based access control. Thank you very much, and I look forward to your questions.
Hello, good afternoon to everyone. My name is Moreira. I'm a PhD in medical science and I am also an entrepreneur and IoT and healthcare consultant. I'd like to start saying thank you to European Alliance to Innovation and Smart City for this invitation. I'm very happy to be here today, connected with all of you and with this so great opportunity to talk some very interesting things about the whole of IoT in the Latin health market and some opportunities and challenges in our horizon. So, to make clear that we're talking very seriously when we talk about these disruptive technologies, especially IoT, I'd like to show you this short video where we are using these technologies in Carnival. So if it's in Carnival, it's because it's very serious for us. I hope you enjoyed it and I hope this inspires you to visit us during Carnival, of course, after the pandemic. Well, today I organized this conversation in 4 main topics, starting with some basic information about Latin America, a few things we really need to know to can start this conversation. Second, the financial gains in the health market for the next few years, especially the gains related with these new technologies, of course, main focus in Internet of Things. Third, academic research and publications related to health markets and Internet of Things. And final, some strategies for the future. When we talk about Latin America, we are talking about a large territory, compound of 20 countries. The population, it's more than 600 million people. It's more than 80% of the global population. And the GDP, it's almost 6 trillion. It's more than 6% of the global GDP. So it's not a market you can ignore. But if you have a plan to reach this market, you have to understand that it's a very diverse territory. There is a diversity of culture, of social, economic, and political realities, and you have to understand all this diversity to elaborate a good business plan to reach Latin America. To understand how the healthcare services in Latin America works, it's important to know that a few decades ago, many of the governments decided to walk through a universalization of access to the services. So we can observe that in a few decades, the number of people who has access to these free services increased from 39% to almost 100%. And the out-of-the-pocket percentage of the cost decreased from 40% to 29%. But to evaluate if Internet of Things it's a possible technology to Latin America, it's possible to our reality, we need to understand how is the connective in the region. So here in this graphic, we can observe the number of unique subscribers over the total population with access to a smartphone. We can see in 2000, we have around 10% of the population with access to a smartphone. And in 2017, we have almost 75%. It was a fast growth of the population with access to this technology, the percentage of the population effectively connected. Here we have some indicators that show us how is the future of Internet of Things in Latin America. So around the world, business interested in explore IoT solutions are 8%. In Latin America are 19%. So Latin America is a little bit more open than the rest of the world to this new technology. And the capital expenditures in 2000 was less than $1 billion per year. In 2017, it arrives in a patamar of 3 billion with some peaks of 4 billions. So it's a very important improvement. And the number of Internet of Things connections in Latin America in 2017 was 400 million objects and expected to arrive in 1 billion until 2023. And the economic value of Internet of Things connections in Latin America in 2017 was 4 billion, and it's expected to achieve 19 billions in 2023. But why IoT? What exactly the CEOs and the decision makers are looking for when they look for IoT solutions for their business? 35% are looking for improvement in products and services. 29% are looking for support in the decision-making process. And 28% are looking for data analytics. So these are the most welcome solutions according to the CEOs and the decision makers in Latin America. Here I bring some information about the academic effort, the research and development effort in the Latin American countries. So in the last decade we have 38 scientific articles published. So in 2019 was the biggest number of articles. Also, we can see there is an improvement every year, despite the number is still not very high. These numbers are the result of the research of the terms Internet of Things or IoT and health or healthcare in the US National Medical Library. 23 of these publications are a result of research projects with no partnership with countries out of Latin America. And the other publications are part of projects with partnership with other countries, most part of them countries from Europe and North America. And here we can see these scientific publications per country. So we can observe Brazil has a strong leadership in Latin America when we talk about Internet of Things research and development, with 55% of the publications, followed by Colombia and Mexico. And now I'd like to present you another video. This video doesn't have subtitles in English and presents some solutions developed for SPI, a Brazilian IoT company. And these solutions are already implemented, helping the clinic hospital, the biggest public hospital in Latin America, to fight against COVID. Basically, you have one solution for garbage management with a robot, and IoT being used in intensive care and platforms to remote care of patients with chronic conditions. And these patients with chronic conditions don't need to go to the hospital during this pandemic period we are living. So basically here we have countries, a group of countries with a population aging fast in the last decades. So because of this, facing many challenges in the health services area and finding possibilities in these new and disruptive solutions. But it's very important for these countries the possibility to develop their solutions, not just import finished products from other countries, but develop their solutions to have this possibility to understand what really fits to our reality, what really fits to the profile of our population, and became protagonist of this process of health digitalization and democratization of access to the health services for this so diverse and populous area that's Latin America. I hope you all have enjoyed, and now I am ready to answer your questions.
Hello, Mischa Dohler here. I'm professor at the engineering department of King's College in London. And I thought to give you a little bit of an overview of the research we're doing on digital technologies such as 6G as well as smart cities. Now, my personal relationship with the digital world and with the cities world actually stretches back, almost 15 years now. And notably, I've been very active in all things smart cities through my company, World Sensing. We have pioneered loads of the notions which are being used today within the context of smart cities, such as smart parking and other things. And at the same time, being professor in all things digital, we work very strongly on the 4G, 5G, and now 6G developments. So I thought combining both and just show you a little bit on how I personally think, that ecosystem will evolve. So let's get on with that and see whether 6G and smart cities actually have any synergies. So here's a slide which I've actually been using over the last maybe 10 years, and it hasn't changed at all. And it is really to show you that when we talk about smart cities, we still have a very big divide between smart and city. So we have on one end all the digital things, IoT, sensors, actuators, 4G, 5G, hopefully in the future 6G, all the artificial intelligence, data, platform, other, edge cloud compute capabilities and all that. And on the other side, we have city, meaning roads, streets, traffic lights, parking meters and all that. And whilst, both are coming closer, I still see that, the city people not necessarily speak the smart language and the smart folks not necessarily speak the city language. So we still have that chasm between these two worlds where, we don't really yet have a smart city. We have smart and city. And I think, one thing we still need to do to bring these ecosystems together. And let's see if we can get it going through one of the things I wanted to do for many, many years. And that is to completely transform mega cities. And the idea is really to get rid of all the cars, all the transports, all the buses, everything which runs on the roads, and replace that really by pedestrian areas, bicycle areas. Now, the inspiration to this came maybe 10 years ago when I was by total coincidence in Israel at Yom Kippur. And those who know about Yom Kippur, they know that essentially, it's a very big religious festival for the Jews, and Israel just stops functioning. Even the airports, nothing works. So I was there with my friends on the highways in Tel Aviv, barbecuing. And I just thought, this is phenomenal. Pollution's gone down. People started to truly re-own their urban infrastructure. And I remember I flew back, and back then Boris Johnson was still our mayor. And we talked to him about it, and he then promised to look into this for London and introduce the last weekend in September a car-free scheme. So this is how it all started. But of course, it's just one day, and I wanted this for a longer period. And of course, there are cities who are doing that already. So there are quite a few cities out there, but there's no mega city. There's no London. There's no Buenos Aires. There's no New York. There's no Beijing or Moscow, Berlin, who are really going fully green, completely get rid of cars. So this is really what we wanted to do, and I started to study it from all the possible angles to figure out whether this is actually doable. And if we wanted to do that, we actually really needed to make sure that cars, ambulances, buses, motorbikes would transit to trains, underground, cycles, walking. And the same is not only for the citizens, but also for the industry. There's a lot of stuff happening in the mega city. The supply chains, there's construction, there's a lot of, waste management going on. There's a lot of stuff going on in an urban city the size of London. And therefore also that needs to be transited into more sustainable form. And I figured, once we really manage to do that, and if we are managing to do that, what would that lead to? It would essentially allow us to have many more people cycle, many more people walk, and people not being afraid to cycle, because it turns out, a study has been done recently by the Bicycle Association here in the United Kingdom. People are afraid to cycle because there are too many cars and buses and trucks and all that on the road. It scares people. Naturally, we hear about a lot of deaths, accidents. So if we got rid of all that heavy duty four-wheel type of traffic, wouldn't it be great then to liberate that space for cyclists and for pedestrians? Now, we all understand that pollution will go down, so that's a huge health benefit. People will walk more, will exercise more, which is yet another huge benefit. So therefore, the bottom line cost and the top line opportunity, business opportunities, seem to be a no-brainer. So we started thinking on how to do that. And the way we think this can be done is, by addressing three challenges. And these challenges are in urban engineering, in transport engineering, and in digital engineering. So these three things. And I will talk you through each of these because we looked at each of these. And of course, I'm really a designer very deep in the digital engineering side. So let's start with the urban engineering. Now, I have to say that I'm not an urban engineer, so this is really just looking conceptually at what could be done, and then the real professionals, the real urban engineers, should take over and essentially do that properly. But here's some outline, just some ideas on how we could approach that problem. Notably, we looked at a citizen's life in general. What do people do in a city like London or New York or Beijing as an example. So clearly we wanted to understand, how easy is it for people to access the underground? So the underground transport, of course, should be there because it will absorb a lot of the overground, traffic, which we are now trying to get rid of in a sense. So, how easy is it to get to an underground from any point in the city? How easy is it to get actually to a city biking spot? There are loads of them in big cities now where you can rent these bikes and then really cycle through the city. So how easy is that? And then what shall we do in very special situations? Weather is bad or, emergencies need to be dealt with. So this is how we looked at it from a citizen's point of view. And then, of course, we need to care for the disabled and the elderly because there will be quite a few people which need extra help, and they have been very reliant on buses and taxis before. So we started to look from a capacity analysis, purely capacity, as a macro view in a city like London. We said, what's the bus usage today? What's the car usage today? What's the underground and train usage today? And what's the capacity around this? And could we make use of, rivers or airspace? Flying taxis are coming. Couldn't we use that? So we did that capacity analysis, and then we also looked very, very diligently into the reduction on emissions. So how much health benefit do we get from an air quality point of view? We also looked at the exercising benefits. So I will not present all of that because there's quite a bit of stuff. I'll give you a few snapshots of the work which came out of that. So here's the example of the accessibility in underground. So we used a tool called MATLAB, and we spatially mapped all the underground stations, and then we just run a random point model where people could be. We haven't even used a true street model. So in fact, the analysis we have here is probably a worst balance. So we found out that from any point in central London, so we looked at zone 1 and 2 here, we didn't go into the further zone, so we really focused currently at the core of the nucleus, of the urban nucleus, and we found out that from any point you find at least one underground station within 10 minutes walking. Okay, so no matter how hard you try, within 10 minutes you can reach an underground in London within 10 minutes walking. So that's really great. With bicycle, you'll be even quicker, and in most of the cases, you will be even quicker than these 10 minutes. So that's about 10 minutes. And then we looked, what about 2 or 3 stations? So you see the result here for 2 stations within 15 minutes. You have at least 2 underground stations, so you have a little bit of choice there. You don't necessarily need to change the underlines underground. So that's a great result, because 10 minutes walking to an underground is really not too arduous. You can do that. You can expect that from the citizens, which aren't the elderly and the disabled. We then did all that capacity calculus, and we figured out, actually, guys, it's doable. It's really doable. So we worked out, what's the bus capacity at the moment, the bus usage at the moment, the car and taxis usage today, and we came up with this nominal number. You see it on the screen, 45,249. So this is a number which is a special unit we created. It's a certain number of passengers or citizens per time per area. And then we looked at, the increase based on the past increase of that number. We have seen that this number increases about 1% per year. And we figured out that, the true capacity on the train undergrounds and train lines is 54,000. And at an increase of 1% per year, you suddenly have a crunch in the year 2039. So therefore, this was done pre-COVID, not doing any investment into trains and undergrounds, with the current infrastructure, just removing all the buses and the taxis and the cars in London. You'd be able to run until the year 2039 without really hitting capacity crunch. That's great. It's 20 years to go. Okay, it's 20 years to go, and we can imagine there's more forms of transport appearing, such as air taxis and rivers. The rivers being used a bit more. We can also think of more investment in the underground. So it is really doable. We can push this number probably to many years ahead, but 20 years ahead seems to be very good. It's doable. So we can do it from a capacity point of view. We then also looked at the industrial aspects. Of course, the city is not only people. We have supply chains there. We have construction there. We have, various, services running within the city, which now also need to be replaced. So first thing we examined is if we couldn't just shift them to the night. So one thing we have been looking at is to see, what happens if we actually start, using some of these supply chain construction services, let's say from 10 o'clock at night until 4 o'clock in the morning or 5 o'clock in the morning. So there's a working shift clearly from the people involved, but it would liberate the roads and the streets in London during daytime. We also looked at the parcel delivery. We looked at waste management. I will not talk much about this, but we have done the exercise and we figured out it is actually doable. An example here from a supply chain point of view, we looked at the warehouse distancing. So the same as we've done with the undergrounds, we looked at the warehouse distancing and how could you reach it in the form, if you had to do it during daytime, how quickly can this be done? And we figured out within half an hour using, transport modes which aren't trucks or which aren't, the wide vans which are typically being used. And I'll show you some solutions later on. You can reach any of these points within 30 minutes, which is great. So it's doable. It is not really a huge challenge to address that. And also remember, folks, we can have the city run at night where basically we expect nobody to be on the road from a cycling point of view. So then we looked at the transport engineering challenges. What could be done there? Now, again, I'm not an expert in transport engineering at all, but we started looking at it. So we didn't design flying taxis. We didn't look at special ways of using the river, but we had some other thoughts which we thought would be very low-hanging fruits of making. We thought specifically about the elderly and disabled. So there are tools coming out now where people can really, move through the city on trolleys. They're very slowly moving on wheelchairs, automated wheelchairs. How do you absorb them now into the underground? How do you make that happen? So, instead of constructing more step-free underground stations, so how to keep the investment low, we thought of modifying, let's say, the escalators or introducing wheelchairs which are able to actually go down on escalators. So we've done that. We've done much more. It's just a little snapshot there. So an example I'm giving here on how to deal with the elderly and with the disabled. Another example we looked at is how to improve this space in the underground. So rather than having seats everywhere, we thought of keeping seats for the elderly and for the disabled, and those are very tired, women who are pregnant, people in need who really need to sit down after maybe a 10-minute walk to the underground. And we figured out that if we start removing seats in certain parts of the section, we are suddenly opening up a capacity which is phenomenal in the underground, allowing more people to travel. Now, this, of course, this design was pre-COVID. So therefore, we assume that at some point the COVID crisis will be dealt with, and also the traffic, probably the density of people in the city is much lower now. But we just wanted to show it's possible to increase, the capacity of the underground itself. And also we designed, now that I see the underground, we designed essentially parcel sections where part of the one wagon of the underground is being used to essentially ship goods through the city, post, parcels, etc., which could replace some of the overground, deliveries. We also looked at new cargo bikes. Don't laugh about this, but we thought, let's just give it a go. 4 cubic meters, that's phenomenal. That's really a lot. So we looked at it from a design mechanics point of view. And you see something here on the screen. I'll leave, that to the real pros. But in principle, 4 cubic meters is a lot of space. So you can really load a lot of parcels in there, a lot of goods. You see some of these already being used at smaller form in London, such as Pret-a-Manger has been doing that to have a more green form of transport between their shops and kitchens. And we thought of expanding that, making it bigger, and essentially be driven by green energy to get goods from one part of the city to the other part. So let's make an interim conclusion here before we move on to the the digital side. So it is doable, folks. It's doable. A city like London can actually go entirely green. We can make sure that there are no cars, no buses, no taxis, no 4-wheelers, 6-wheelers, 10-wheelers on the roads during daytime. Nighttime, very specific nighttime is a different story, but during daytime, this is doable. We can make it work. There are enough underground stations there within walking distance. There are enough biking stations in there within walking distance. The underground does not saturate, until 20 years from now, and that is a pre-COVID estimate. So, and this is also assuming there's no investment going on. We also are able to see that a huge amount of carbon dioxide will be reduced, and the pollution in general will go down. And remember that it's not only the exhausts which provide the pollution, it's also the wheels of the cars which during braking release a lot of these toxic materials, something you will see much less with cycles. So therefore, a huge amount of toxicity goes down in the cities. People will be healthier, the load on the NHS will be lower. There are challenges to be overcome, habits to be overcome, but it is doable from a citizen point of view. Industry will push back naturally, so there's a lot of things we haven't looked at, for instance, what to do with the, tens of thousands of taxi drivers in the city. They need to be retrained probably. We need to come up with new schemes there. But in principle, the big industry, supply chain, construction, parcel industry, all that is doable. We can do that. We worked out schemes. We looked at capacity, and we are able to run London during daytime without vehicles. bicycles, opening up the space to people. People can have barbecues again on the roads. They can go with cycles, with their children, with their pets. Nobody should be afraid to be on and own that public infrastructure. So that's quite exciting. So let's move on now to the digital side. Now, from the digital engineering point of view, of course, that becomes very interesting because we will clearly change the the demographics in the city, and COVID has accelerated that even more. And there will be huge changes in working patterns, commuting patterns, being at home patterns, and therefore the big. Now, before I start doing this, let's look at the trends, and that's quite an important slide actually, and hopefully it's quite helpful to you as well. And this is how I like to see my ecosystem, the telco ecosystem. And you can see that as we went from 1G to 2G, 3G, 4G, 5G, now 6G, telco always follows that very constant trend. It almost seems to be a law similar to Moore's law, but just for telecom. And something always improves by an order or 2 orders of magnitude, whether that's the data rate or that's the latency or the reliability or how many devices you can connect. So it is always improving very reliably. So you see essentially that arrow there going up, that black arrow, and as we went through time from 1G now to 5G, we started to be able to serve different communities. So 2G, 3G, 4G was mainly about people. We went from voice call, to an internet, to truly flat internet, really highly performant internet with 4G. And with 5G now we start to see that the KPIs are so good, so brilliant, that we're able now to serve not only the citizens, but also industry. And the reason is because mainly it's the reliability really gone up. It's really good reliability, but also the latency has improved now to an order where it becomes interesting to replace some of the industrial Ethernet cables we see in manufacturing halls. So with latencies of a millisecond, or maybe up to 10 milliseconds we observe in 5G, suddenly you can get rid of cables in manufacturing halls and therefore save a lot of cost. You can have 5G plugged in an edge cloud, actuators and sensors work in unison to design your perfectly, a personalized car. And these type of things we can do these days. And car maybe is a bad example because I'm trying to get off cars. Let's say bicycle, right? So you're perfectly kind of personalized bicycle. So these type of things we can do now with 5G. And, if we believe the trend, 6G will improve on that. And I put a blue box up there because maybe we'll be able to serve something else. I have some ideas what that something else might be, but we are seeing, we are now chartering into new territory. I would also like to for you to pay attention to another set of arrows I drew down there, which are the blue arrows, which always draw from 1G to 2G, 3G, 4G, 5G to 6G. So essentially from the uneven or the odd generation to the even generation, and this is because it seems like it always takes us about one generation to truly embody what we wanted to do with the previous generation. So in 1G, we wanted to have this global calling, untethered calling capability. It was a starting point, but we wouldn't call it a success. The success was 2G. Okay, it was really 2G. In 3G, we wanted to introduce the internet to the mobiles. It was a first step, but I wouldn't call it a success. 4G was a success. So when you have your 4G phone today, when I'm using my phone today and I have 4G, I forget I'm on 4G because the connectivity is so good that actually it's just a truly seamless experience. Now in 5G, we start to bind in industry, and these will be very first steps, and they're important steps. You can't take the subsequent step without doing the previous one. So we need 5G, but it will really be 6G, which will then kind of embody that full capability of the industry, which we have industry connectivity. So I just wanted to show you these two trends. So there's really regularly increasing trend, as well as that consolidation trend from the odd to the even generations. Now with that at hand, we are now able to really understand what is 6G going to be about. So when we look at it, what was 4G, what is 5G, what's 6G, you follow the trend, you can do the exercise, right? You can do it. I show you here, for instance, the average experience data rate by a user in 4G was 10 meg, in 5G it is 100 meg. So therefore, we know by virtue of the trend, we multiply the 100 meg by 10, and in 5G might be called IMT 2030. I don't know yet. I made up this name, but in 6G we will have 1 gigabit per second, right? We have it. Latency, the user plane latency, so meaning the time it takes for you to press a button and get the response from the website, or to get your sensor react or your actuator react to some sensing input, will go down to 0.1 milliseconds. And there will be other KPIs which will improve. I won't spend time on this, but you get the gist, right? So we know how 6G will look like. We don't know why it should look like this, and we have no idea how to do it. Okay, so that is now the road we need to do over the next years as engineers to come up with that, and the business people need to come up with ideas. But I want to quote a really good sentence I borrowed from Hans Vestberg, the former chief executive of Ericsson and now chief executive of Verizon, and he said, "Look, guys, we started designing 3G when the internet wasn't around. We started designing 4G when the iPhone wasn't really around. So therefore, don't get too bogged down. What's going to be the kill out for 5G, 6G, etc. It will come. We shouldn't worry about it. We know we need to deliver it for 6G, a gigabit per second. We still don't know exactly how. We have ideas, but we don't know exactly how, and we still don't know why. But we don't panic because we know the why and the how will be answered." So what is happening then from an application point of view? So we pre-published a really interesting paper. You see it here with my co-authors, friends, and colleagues around the world. It's called 6G Wireless Systems: Vision, Requirements, Challenges, Insights, and Opportunities. And it is leveraging on this trend, essentially showing, what will we consolidate with 6G, what we started excitingly with 5G. And you see a lot of items on here, and you see a lot of KPIs here, data rates, reliability, and you will see it has been multiplied by 10 or divided by 10. But I would like you to look at that smart cities, icon, because we believe that really 6G will be an instrumental, technology within smart cities, an aggregator of a lot of data, the ability to process that data, so essentially consolidate what we wanted to do with 5G and the IoT ecosystem. So therefore, we believe 6G will really be instrumental. It will bring, really that immediacy, hopefully, that immediacy which we have been dreaming of for so long. Let me really kind of spend a bit of time on this one, and it's really, show you what kind of what possible applications we have there in the cities. And I'm cherry picking here a little bit, but those who know my work, they know I've been dreaming of this new internet. This new internet which comes as a natural sequence of the traditional internet, the mobile internet, the things internet, or internet of things as we call it. I wanted to have an internet of skills. So I believed in 5G, now 6G, being able to democratize skills the very same way as the internet has democratized information. And you see here on that slide, we did a lot of coverage down this work, and I wanted to drift away a little bit from this Industry 4.0 thinking where we are essentially empowering machines. I really wanted to empower humans, you and me, anybody who has a talent in any form. Could we transmit that talent? And it turns out, with 5G, 6G, we're able to do that. Think of it like a digital twinning, a teleportation of your skills. But, the idea is to bring you very, very close to a level of immediacy in a full immersive type of environment to any other place in the world. We can think of, the Rolls Royce or, the Vauxhall engineers or the Tesla engineers being in their factories or at their home even, and helping maintaining the engines or the cars, the machines, everything, remotely. We can think of this scenario like that, or somebody teaches me how to paint without actually being with me, or I teach people how to play the piano. So that Internet of Skills vision really requires, this low latency network, which will, I think, really be consolidated with 6G, and that will change entirely the demographics in the city, because a lot of the commutes will really fall through. You will be able to do things, from your home, maybe from an office which is nearby. So therefore that dynamics will change. And we will start introducing what we call a holographic society. So what happens if you start fully holographically mapping the environment? Well, you need to transmit, 4.32 terabits per second. Now, this is a terrible data rate, really. We will have new ways of dealing with that, and we've seen recent announcement by NVIDIA to use AI to essentially predict a lot of the visuals on both ends. So this will come down, but clearly, new forms of engagement in the urban environments powered by the Internet of Skills and holography will allow us essentially to unlock entirely new services and change the demographics in urban environments. So it's really that 6G will probably be at the dawn of a very human-centric era. It's really about us humans, Internet of Skills. It's really about you, me, anybody in the world democratizing their skills, very human-centric. It will be underpinned by loads of machines, artificial intelligence, and it will, facilitate these yet-to-be-designed applications and services. And the interesting thing is also, because a lot will be driven by AI and by, machines in general, these services will likely be generated on the run. So we're not talking anymore about a very discrete set of services we are used to. We're talking about a spectrum of services, services which might be ramped up in a millisecond and then ramped down a millisecond later. So we will have that type of ability of the network, which overall, as an aggregate from an macro point of view, will support, a human-centric era. So that's really it from my end. And I'd like to thank you to stay with me for that mini keynote here. You're most welcome to contact me on the various aspects I've talked about. But let's work together to make our cities, our big mega cities, truly green again. Thank you and greetings from London.